So next program is on Bezier curves. PT is a continuous function in the 3D space defining a curve with n discrete control points. Then t is equal to 0 at the first control point I is equal to 0 and t is equal to 1 at the last control point I is equal to n. So that means the control points are given and we define a curve with the n discrete control points. And this is one example of defining a curve using n control points. So here you have P0, P1, P2, P3 and P4. So the curve that is formed you can see here. So P0, P1, P2, P3 and P4. So n is equal to 4 and it is because 4 minus this is totally 5 points. 5 minus 1 is 4. Now consider an example, that is a equals to 2, that is 2 points. The x is equal to x1, x0 equals 2, y0 equals 2, and this is x1 equals 3, y1 is 4, x2 is 5, y2 is 4, x3 is 7 and y3 is 5. They are totally 4 points. So n is equal to 4 minus 1, that is equal to 3. So you have P0, P1, P2 and P3. Now equation of a Bezier curve. So it is sigma k equals 0 to n, pk and bk of n of u. So k equals 0 to n, that is n of k, and u of k into 1 minus u power of n minus k. So that is k equals 0 to n, then n factorial divided by k factorial into n minus k factorial into u power of k into 1 minus u to the power of n minus k. So this is the formula, that is Bezier curve formula. Okay, so now n is equal to 3. Now it starts with P0, B0 and 3 of u, P1, B1 of 3 of u, P2, B2 of 3 of u, and P3, B3, P3 of 3 of u. Now substituting this formula, substituting this formula, we'll be getting P0 equals P0 into u 1 minus u to the power cube, P1 into 3 factorial divided by 1 factorial into 3 minus 1 factorial, u into 1 minus u square, and this is the formula, this is the equation you get. And this is by substituting these values, by 3 factorial becomes 3 factorial divided by 2 factorial into 3 minus 2 factorial, this will be 3, and this one will be 3, and this is the same, and here this is the same. So this is substituted with x and y values. This is x values, 2, 3, 5 and 7 are the x values, 2, 4 and 5 are the y values. So it becomes x0, x1, x2, x3, y0, y1, y2, y3. So for x values and y values. Now substituting this for x of u and y of u. The same formula is used for x and y. So let us look at substituting. U is ranges from 0 to 1. So with a difference of 0.2. So it is starts with 0 to 1 with a difference of 0.2. 0.2 is 4, 6 and 8. So substituting these values in this equation for x of 2, when it is 0.2, we get the value as 2.71, and substituting the same formula with y is equal to 0.2 and u is equal to 0.2, that is 2.984, and similarly all these values here. Now plotting this you get, so x-axis and y-axis, so here the points P1, P2, P3 and P4, and this is the curve that we are getting. Okay, so this is the curve we are getting this is the Bezier curve, okay, for this example, for this given input. So now let us look at the program and we'll see how we are getting the output. So this is the, let us look at the program, and this is the binomial part, and this is calculating the formula part, this is the displaying the Bezier curve part, and this is the, every time we are changing the angle by theta, by giving the theta, so that is this part. And we are trying to display the continuously different types of lines, okay. The number of lines are displayed, many lines are displayed, that is first one, second one, third one. There are 3 different types of lines with different colors are displayed, and we are getting the output. Now we'll see at this is the main part, code explanation. We'll see at the code explanation. So this is the main part. We initialize the graphics utility toolkit. We initialize the display mode as discussed in the previous classes. Initialize the size of the window. Initialize the position, and we call the display function. And here the next part is this is the formula we have seen for the Bezier curve formula. And here the first one is, here it is k plus 1. This part is n factorial divided by k factorial. So it is n factorial divided by k factorial and n minus k factorial. So what is this part, n factorial, k factorial, n minus k factorial is done in this part of code. Okay, so this part of work is done in this part of code. Then how it is done is, you can see here. So it is n factorial. So it starts with n. So j is equal to n, and j is equal to n, and it is reduced and multiply the j value with a new value of c of k in an array. So it is multiplied. It is nothing but multiplying this value. But it says k factorial. So it says k factorial. How is it? How is this n factorial and k factorial? Because here we are saying k plus 1. So when we say k plus 1, we don't need to take k factorial. So it is like this. If it is 6, then we are multiplying from 6, 5 and 4. 3 and 2 are not taken, because if k is equal to 3, then if k is equal to 3, then it is 6, 5 and 4. So the 3 is not taken. So 3 into 2 are not taken. 3 into 2 is 6. Again 3 into 2 is. That's why it is k plus 1. Instead of taking k factorial, we have just taken this n factorial. That's all. So this part is not there. So this part is avoided, we can say. So because of, by taking k plus 1. And the next one is n minus k, dividing by n minus k factorial. So that is this one. So n minus k into j minus minus. So you're multiplying it and you're dividing with n minus k. Okay. So next one is, so you have this 1 that is 1 minus u to the power of n minus k. So that is 1 minus u. So this is 1 minus u to the power of n minus k. 1 minus u to the power of n minus k is here. So you can see here. You can see here. So that u power of k is here. U power of k. And this is multiplying with c of k. So this is c of k. We have just added this whole part into c of k. So you are adding it, the whole part into c of k and multiplying. So this is the function. We are using pointers to call the values of it. So that is the basic C programming part. So pointers, we keep the values so that you have understood, you know already. Okay. So now this is the binomial factors. How do we call these things? So it is the we pass this n and the input points. Okay, input points are passed, and this is n value. So n minus 1, the given value, you define n value here. So that is given value minus 1. So that is n minus 1, and c you get this part. Okay, and the next part here we call the u value is calculated. It will be 0.2. So it defines. So based on the it is based on the it starts from 0 to 1, and based on that you can define the u values, and u values is defined here, and u value is called, again u value is passed here, and these are the points Okay, so passed, and you calculate this function. So after this calculation of this function, and it is summed up, okay, sigma, it is summed up. So you say it is repeatedly called and it is summed up, and the resultant is plotted here. And now here this is the theta, and theta is initially it is 0. That means it is drawn once, okay, increment with 1 degree and repeat it, same thing, same calling the same function. So this is for, this function is for to call the single one line of width. A line of width is drawn, okay. So now the 12 times this line is drawn with this color. That means that is a saffron line is drawn with 12 times with this color, and again the white color is drawn with this 12 times with white, okay. So again with a translate of again in the green color, it is 12 times, it is drawn with this translation and this Bezier curve. So this Bezier curve is called the function, okay, and the line is drawn, and this is for the pole, okay. So now how would it look, how would the output look like? So let us see. So it looks like this, you can see the output. Thank you.